The human brain is a marvel of nature. It is an organ of immense complexity and beauty, a true masterpiece of biological engineering. From the moment we are born, our brains begin to shape our understanding of the world around us, processing vast amounts of information every second. It is an intricate network of billions of neurons, constantly firing and communicating with each other. These neurons form connections, known as synapses, which allow for the transmission of electrical and chemical signals. This communication network is what enables us to think, learn, and remember. This complex organ is responsible for everything we think, feel, and experience. Our emotions, memories, and even our sense of self are all products of brain activity. It is the seat of our consciousness, the essence of who we are. It shapes our perception of reality, yet this reality is not always an objective reflection of the world outside. Our brains interpret sensory information, creating a subjective experience that can vary greatly from person to person. Our brains can trick us, distorting information and creating illusions. These illusions can be visual, auditory, or even tactile, demonstrating the brain's incredible ability to manipulate our perception. Imagine a world where what you see, hear, and feel is not always what is actually there. This is not just the realm of science fiction. It is a fundamental aspect of how our brains function. Virtual reality technology, for example, takes advantage of this by creating immersive experiences that feel incredibly real. This is the world our brain constructs for us. A world where perception is a delicate dance between sensory input and interpretation. Our senses gather information from the environment, but it is our brain that makes sense of it all, often filling in gaps and making assumptions based on past experiences. This essay explores the fascinating realm of brain tricks, delving into the science behind how our brains can distort reality. From optical illusions to cognitive biases, we will examine the ways in which our brains can lead us astray, and the implications this has for our understanding of the world. We will uncover the mechanisms by which our brains shape our experiences. By studying brain activity through techniques like MRI scans, scientists are beginning to unravel the mysteries of how we perceive and interact with the world. We will journey through the fascinating world of neuroscience, examining the implications of these brain tricks on our daily lives. Understanding how our brains work can help us make better decisions, improve our mental health, and even enhance our creativity. And exploring the exciting possibilities that lie ahead in unlocking the secrets of this most enigmatic organ. The future of brain research holds immense potential, from developing new treatments for neurological disorders to enhancing human cognition and beyond. Our brains are bombarded with a constant stream of information from our senses: sight, smell, taste, touch, and hearing. Every moment, our sensory organs are collecting data from the environment, sending millions of signals to the brain. This constant influx of sensory information is what allows us to navigate and understand the world around us. These senses act as our windows to the world, relaying raw data to the brain. Each sense provides a unique perspective, contributing to a fuller, richer understanding of our surroundings. For instance, our eyes capture light and color, our ears detect sound waves, our skin feels pressure and temperature, our nose picks up scents, and our tongue tastes flavors. However, this data is not passively received and interpreted. Instead, the brain actively constructs our perception of reality by processing and interpreting this sensory input. It's a dynamic process where the brain filters, organizes, and makes sense of the incoming data, creating a coherent picture of the world. Think of the brain as a master chef, taking in raw ingredients from the senses. Just as a chef selects the best ingredients to create a delicious meal, the brain selects and prioritizes sensory information to build our perception. These ingredients, like light waves or sound vibrations, are meaningless on their own. They are simply raw data waiting to be transformed into something meaningful. Without the brain's interpretation, these sensory inputs would remain just that, raw, unprocessed signals. The brain, like a skilled chef, transforms these raw ingredients into a cohesive and meaningful experience. It combines and blends the sensory inputs, much like a chef mixes ingredients to create a dish, resulting in a seamless perception of reality. It filters, organizes, and interprets this information, constructing a coherent representation of the world around us. This process involves complex neural networks and pathways, each playing a crucial role in shaping our perception. This process of constructing reality is not always perfect. Sometimes the brain's interpretation can be flawed, leading to perceptual errors. These errors can manifest as optical illusions, where what we see doesn't match reality, or auditory illusions, where sounds are misinterpreted. The brain, working with limited information and evolutionary biases, sometimes makes shortcuts, leading to intriguing perceptual errors and illusions. These shortcuts are the brain's way of making sense of incomplete or ambiguous information quickly, but they can sometimes lead to fascinating mistakes. These errors are not glitches in the system, but rather provide valuable insights into the brain's normally hidden workings. By studying these perceptual errors, scientists can learn more about how the brain processes information and constructs our experience of reality. They reveal the brain's remarkable ability to create meaning from the chaos of the sensory world. Despite the occasional errors, the brain's ability to interpret and make sense of sensory data is nothing short of extraordinary, allowing us to experience the world in all its richness and complexity. Optical illusions, perhaps the most widely known type of brain trick, serve as compelling examples of how our brains can be fooled. These illusions are not just simple tricks. They reveal the complex and fascinating ways in which our brains process visual information. When we look at an optical illusion, our brain is trying to make sense of the visual data it receives, often leading to surprising and unexpected results. These visual puzzles exploit the brain's shortcuts in processing visual information, known as heuristics. Heuristics are mental shortcuts that help us make quick decisions and judgments, but they can also lead to errors in perception. Optical illusions take advantage of these shortcuts, creating images that deceive our brains into seeing something that isn't there, or misinterpreting what we see, leading to perceptions that do not match the physical reality of the image. For instance, when we see an image that appears to be moving but is actually static, our brain is being tricked by the way the shapes and colors are arranged. This discrepancy between what we see and what is real can be both fascinating and disorienting. Consider the classic Mueller-Lyer illusion, where two lines of equal length appear to be of different lengths due to the orientation of the arrows at their ends. This illusion is a powerful demonstration of how context can influence our perception. The arrows create a context that our brain uses to interpret the length of the lines, leading to a misperception. This illusion highlights the brain's tendency to interpret depth and distance based on contextual cues. Our brains are wired to use context to make sense of the world around us, which is usually helpful but can sometimes lead us astray. In the case of the Mueller-Lyer illusion, the context provided by the arrows causes our brain to misjudge the length of the lines. The inward-pointing arrows make one line appear shorter, as our brains interpret it as being further away, using depth cues that we have learned from our experience with the physical world. This interpretation is automatic and happens without conscious thought, demonstrating the power of our brain's processing abilities. While the outward-pointing arrows create the illusion of a longer line, seemingly closer to us. This is because our brain interprets the outward-pointing arrows as indicating that the line is closer, again using depth cues that we have learned over time. These automatic interpretations are usually helpful in everyday life, but can be tricked by carefully designed illusions. Another fascinating example is the Hermann grid illusion, where gray spots seem to appear at the intersections of a black and white grid. This illusion is particularly interesting because it shows how our brain processes light and contrast. The gray spots are not actually present in the image, they are created by our brain's interpretation of the visual information, disappearing when looked at directly. This happens because our brain's processing of light and contrast is more sensitive in our peripheral vision than in our direct line of sight. When we look directly at the intersections, the gray spots vanish because our brain is better able to process the actual visual information without the interference of the illusion. This illusion arises from the way our brains process light and contrast. Our visual system is designed to enhance edges and contrasts to help us detect objects and navigate our environment. However, this enhancement can sometimes create false perceptions, as seen in the Hermann grid illusion. The brain enhances edges and contrasts, leading to the perception of illusory gray spots in our peripheral vision. This edge enhancement is a crucial part of our visual processing, helping us to detect edges and boundaries in our environment. However, it can also lead to visual illusions when the brain's processing creates false perceptions. Our perception of color is another area where the brain's interpretive prowess is evident. Color, as we perceive it, does not exist objectively in the outside world. It is a product of how our brains interpret different wavelengths of light. The same object, under different lighting conditions, can appear to be different colors, demonstrating the brain's role in constructing our experience of color. Motion perception is another fascinating example of the brain's constructive abilities. We perceive motion when our brains detect changes in an object's position over time. However, this process can be easily tricked. Think of watching a movie. A series of still images displayed in rapid succession creates the illusion of smooth, continuous motion. This phenomenon, known as the phi phenomenon, highlights the brain's ability to fill in the gaps and create the perception of motion from a series of static images. These illusions, while fascinating in their own right, are not mere curiosities. They provide valuable insights into the brain's complex processes, revealing the sophisticated mechanisms that underlie our perception of the visual world.